Welcome back to Stardust Discovery. So now that we've seen all of this, why are all of these objects that are in space, why are they stable? That's my next question. Why are they not falling apart? Why are they not flying around in all directions? Okay, it turns out that the answer is gravity. And so that will lead us to the next stage of this story. Okay? Now, what is gravity? Now, unlike light, we could see light, at least in the visible. We could see it, but we cannot see gravity. Gravity can only be felt. We cannot see it, but we can feel it. And it's an attractive force. What that means is that if you put two objects together, they have two attraction going on. They have an attraction going on between the two of them. And this is because every object that has mass definitely has gravity. The question now is, how much gravity do you have? So the more massive an object is, the more gravity it will have. Okay? So that's established. So gravity is an attractive force, and every matter has gravity. Now, unlike light, we could see light, at least in the visible. We could see it, but we cannot see gravity. Gravity can only be felt. We cannot see it, but we can feel it. And it's an attractive force. What that means is that if you put two objects together, they have two attraction going on. They have an attraction going on between the two of them. And this is because every object that has mass definitely has gravity. The question now is, how much gravity do you have? So the more massive an object is, the more gravity it will have. Okay? So that's established. So gravity is an attractive force, and every matter has gravity. Now, this is very, very important to note, because just thinking about all of us here on Earth, we are all on the Earth, as you can see from this image. Why are we not falling out? We have gravity, we have mass. The Earth itself is so huge, and so its own gravity is more powerful than our own. In fact, it is strong enough to keep us attracted to itself, which is why we are grounded. We cannot fall out because we are grounded. All the trees, all the skyscrapers, all the high-rise, everything is standing on the earth. In fact, whether you are in the northern hemisphere, just like this area, or in the south, you cannot still fall out. Okay, see, all of this, they don't even feel that they are turned upside down. That is also because of gravity. So yeah, that's how powerful it is. So when you even look beyond the Earth and so in our solar system, how come all of the 8 planets are in place? How come they are in place? They are not merging with each other's orbit, or even just, busting together. Why are they not jamming? So same thing, the gravity of the sun is strong enough to keep everybody in place. So gravity keeps things together. It keeps things together, as you can see. Now, just to bring it home a little bit, because this gravity, I've said, is invisible, but I want to give you a sense of how it operates. So as you can see from this image, there is a web. So it's called gravity web. There's a web that gravity creates around every object, depending on how massive the object is. And that, tells you how much gravity that object also has. Okay? So this web surrounding the Earth, you can see that it has more depression compared to the one surrounding the moon. This is the Earth's moon. And you can understand why the moon also is in place and will not clash with the earth, because gravity keeps everything in its place. One key thing too is that it shapes the object. So the objects you see in space, as you have noticed, they seem to be spherical. Now this is the effect of gravity. It tends to make everything looking that way. You've never seen a triangular shaped object in space or a rectangular shaped object, no. So gravity keeps them looking that way. If you look at this other image, these are not real objects in space, but it just tells you how every object of mass has different gravity. So the smallest one has a little depression compared to the most massive one here. So gravity also helps to shape our universe. Now, still on gravity, I just want to highlight this very important property, which is the fact that it causes bending of light. This is huge because if you look at this image of the sun, if you want to observe a star that has to pass through the sun's gravity, what you see from Earth will be a different position from the actual position of that star. Now what happens is that gravity seems to bend the path of light. Okay? There are technical terms for this, I'm sure you've heard about general relativity, but I don't want to bore you with that. But this is a simple explanation to what is going on. But when you look at this other side, which is leaving our solar system, going into distant universe, so the Hubble Space Telescope was able to get this image, and it shows a sea of galaxies. As you can see, all the objects here are all galaxies, different kinds of galaxies. But what is interesting is how some of them look like filaments. So there is some stretching going on with some of their shapes, and this is as a result of the bending of light. So these galaxies are coming from distant universe, so they have traveled through different objects that have bent their light, and so what we see is a result of light bending caused by gravity. All right, so just to highlight for us how powerful this force of gravity is, when you look at this image here, you will see the demonstration of the light bending that I've said before. But what is even more instructive is that depending on the object the light is passing through, that object will serve as a magnifying lens. And we found this for galaxy cluster. So a cluster of galaxy is when you have 2, 3, 5, even more galaxies bound by gravity, in a place. That's huge. So imagine you want to see an object that is not within that cluster, that is far away, and that light has to pass through that galaxy cluster to get to you. And what happens is that the light will be bent. What the effect of that bending does is that the object you end up seeing, or the image you end up seeing, will now be a magnified version of the actual object. So this other image is now demonstrating to you what happens. So imagine this object behind have to pass through these galaxy clusters to get to you. So this is what you will see. A much bigger image of what you were looking at, which is useful. I mean, we want to see bigger images. So sometimes you see that these things even help us, to do better science. But it's just showing you how strong gravity can be. Okay, I hope this was useful. I just thought to highlight some of these, and then I would like to bring us to a place of landing on this preterm spaceship. Here is the moon. This is the image of the first landing to the moon. This is probably where we'll take it off for today. Like, let's land here. I know it's not Earth, this is Moon, but it's close to Earth. How about try out life in the Moon and see what it looks like until our next time. But I wanted to leave you with this takeaway that light is a form of energy that travels in form of waves and is a guide and a messenger for us, telling us stories about objects it's coming from. And every object that has mass has gravity. And this gravity shapes our universe, shapes our world. So as light allows us to see all these objects and study those universes, gravity keeps us grounded. Okay, and there you have it. I hope this was useful. I believe the next time you'll be looking at the night sky, you will have different perspective now, and you will look at it differently. There is so much beautiful things to discover and unravel just from the night sky. All right. Thank you everyone for joining me, and I will see you in our next video. Do not forget to subscribe and like this video. Bye.